Now we come to the tricky last question here, which says, activity A can be crashed by up to 4 hours at an additional cost of $90 per hour. This may reduce the minimum completion time for the project, including activity X. Determine the least cost of crashing activity A to give the greatest reduction in the minimum completion time of the project. To answer this question here, we're going to be using the table method. And what you're going to copy out into your notes here is this right here. So let me explain what this is before you start writing it down. So what I've written here is I have written down all the pathways from the start to the end. So let's consider the first one for a moment. X, G, K. So that would mean I go X, then G, then K. So as you can see, it would be 7 plus 3 is 10. 10 plus 7 is 17. And that's why we've got 17 here. Or maybe I go A, C, G, K. So A, C, G, K would be A, C, G, K. 5 plus 6 plus 3 plus 7 is 21. And that's what we've done for all of them. Now, as you can see, doing it like this, listing all the possible pathways, allows us to figure out what the critical or the minimum completion time is going to be, because as you can see, the biggest number here is 21, and that's what we found the minimum completion time is, 21. So what we can do now is we can apply the maximum reduction to each of these paths. So that is reducing activity A by 4 hours. So let's figure out where activity A is. Activity A is in this pathway, this pathway, this pathway, this pathway, this pathway. So let's reduce all of those by 4 hours. But I'm actually going to rewrite all of the new times. So for instance, 17 doesn't change. 17 stays as 17 because there's no A in that pathway to reduce it. But 21, if I reduce it by 4, will become what? It will become 17. 20 reduced by 4 will become 16. 12 reduced by 4 will become 8. 18 reduced by 4 will become 14. 19 reduced by 4 will become 15. Now, do you see here that I don't have an A? So that means 18 stays as 18, 10 stays as 10, 16 stays as 16, and 17 stays as 17. So now looking at this, what is my new biggest number? Well, my new biggest number is going to be 18. Now, this is where you have to, have your wits about you here. This is the important thing. Do you notice how we didn't make any reductions to this pathway at all, but now it is my new critical path. It's the new 18 here. So what you really want to do here is you want to focus on the ones that you've reduced. So I've reduced these ones right here, right? These are the ones that I've reduced. What's my biggest time here of the ones that I've reduced? Hopefully you can see the biggest one here will be 17. That's the biggest one that we've reduced. Now, by reducing 21 all the way down to 17, by reducing it by 4, we've achieved this result of getting it to 17. But by doing that, we've created a new critical path. So what that means is that you shouldn't actually reduce this one by 4. Rather, what you should do is reduce it by 3. And if I was to reduce 21 by 3, so if I was to go 21 minus 3, that's now going to become 18. Do you see how my minimum completion time is still 18 if I reduce it by 3 or if I reduce it by 4? It's still 18. It was pointless to reduce it by 4 to make it 17 because my completion time is still going to be 18 because I created a new critical path. Therefore, it is better to reduce it by 3 hours because you've done it more. You've achieved your greatest reduction for a smaller cost. So that means it's going to be A times 3, which is 90 times 3. It's going to be $270 here. Now that is the thinking that goes behind it. And that's why the table method can be so helpful in thinking this through. So hopefully that's made sense of how to use the table method to get our answer for these types of questions.